Question 1. Assume that a 50-volt voltage drop occurs across an element from terminal 1 to terminal 2. So you have an element, terminal 1, terminal 2, and there's a 50-volt voltage drop. Okay, so when there's a voltage drop from terminal 1 to terminal 2, it means that terminal 1 voltage, just if it is V1 and if this is V2, so there's a drop, meaning that V1 is 50 volt more than V2. You know, for example, put a 50 volt here, meaning that V1 is V2 plus 50. Okay, whatever V2 is, this is 50 volt higher, or vice versa. Whatever is V1, because there was a drop, V2 is V1 minus 50. Okay, so just think about it, what happens. Anyway, so this terminal is 50 volt higher than the other terminal. You can also say plus minus 50 volts, meaning that this is 50 volt more than this. Okay, this is as far as voltage. And as far as current, it says a current of 250 milliamp enters terminal 2. So terminal 2, the current is 250 milliamp entering terminal 2. So this is the description of the problem given here. Now, what is expected to do? Part 1, specify the values of V and I for the polarity references shown in figure A. Okay, so we have two different polarity references, and we would like to just find this value, this V and I for each case, and then eventually I think we need to do the power. Okay, very good. So let's look at the I here. The I, the reference, is showing this way, but the actual I, 250 milliamp entering terminal 2. So when it enters terminal 2, it's going out of terminal 1. So basically, if this is 250 milliamp this way, it's going this way. So the I is in a reverse direction. So the I is like this way, right? So therefore, the I would be negative 250 milliamp. So I would say I is negative 250 milliamp. It's about the reference, right? Okay. So if the actual current is going that way and my reference says I here, then it has to be negative, right? Because it's a different direction. So that's I. And then how about the V? V, fortunately, is just the same direction as this. So V would be just 50 volts. Terminal 1, see, terminal 1 minus terminal 2. And based on the problem that we had, we said terminal 1 is 50 volt higher than terminal 2, right? So that's the 50 volts. So that's V and I. And then next, we need to find the power. Okay. So to find the power, there are two ways, I would say, to do that. My preferred way is to look at the positive V. Okay, so reading that from plus to minus, which I just put the V for that. And then I consider the I that is entering the element from plus terminal to negative terminal within the element, exactly on this, like this. Whatever the value of I is. So the value of I happened to be negative 250 milliamp. So the whole thing would be negative this much milliwatts. Okay, this is one way of doing that. The other way of doing that, if you want to consider this, we say, okay, my V was, let's put the V here, 50 volt. And so this is 50 volt. And if the I is going that way, so it is not a sign convention. So I have to consider the negative. Whatever it works for you. We have P as that. Calculate the power. Okay, now let's look at another reference. Let's say another student picks this kind of references. So it's arbitrary. The reference is arbitrary. So V plus is here, meaning that the V defined in this case defined as terminal 2 minus terminal 1. See what this plus and minus in this figure says? Terminal 2 minus terminal 1. We have terminal 2 minus, we have terminal 1, okay? And if you look at here, terminal 2 minus terminal 1, because terminal 1 was higher, 50 volt, so terminal 2 minus terminal 1 would be negative 50 volt. Okay. So this is negative 50 volt. How about the I? I the same again. If the 250 milliamp will go in that way, then the I, which is in the different direction, is negative 250 milliamp. So the I is still negative 250 milliamp, and the P equal to V. Let's say look at the positive V, which is negative 50. And let's see, from plus to minus. Negative times the current that is going through the circuit, which is 250 milliamp. Very good. So it becomes again negative 125 milliwatts. So as you see, the figure A and figure 2 ended up to have the same power, and that makes sense because the only difference between figure A and B is just the references, and the power doesn't have anything to do with the references. At the end of the day, the circuit is consuming, or an element is consuming or just generating some power, no matter what is your reference. This reference is just for you, for our calculation. So yeah, so we got the same power, and it's negative. It's negative, meaning that it's actually generating the power. So the circuit is, it says, is the circuit element absorbing or delivering power? It actually delivers power. Because the power was negative. Okay.